Our lesson today is to be able to use variables and evaluate algebraic expressions. We have a couple terms that we're going to use throughout the lesson. First, we have a numerical expression. That's a mathematical phrase with only numbers and operation symbols. Some examples of numerical expressions would be 8 plus 5 minus 2. Notice that there are no variables, just numbers and operation symbols. 25 times 4 minus 9 squared times 3. That's a second example of a numerical expression. Notice just numbers and operation symbols, no variables, right? No letters that represent numbers. In our third example, we have 7 minus 6 divided by 3 in parentheses times 2. Once again, it's a numerical expression because it has numbers and operation symbols, no variables. Well, what do we mean by a variable? Well, that's our second vocabulary term. Variable is a symbol that represents one or more numbers. If I look at this expression, we have the variable n plus 2. I would read that as a number plus 2, or I would read it as the sum of a number and 2. The letter that represents a number, that's your variable. In another example, we have 7 times a number minus 2. The letter B, that's your variable. That's the letter that represents a number. Our third vocabulary term, an algebraic expression, that's a mathematical expression with one or more numbers. Some examples of algebraic expressions would be a number plus 2. Notice the variable n in the expression. Or we have 7 times a number minus 2. Notice the variable b in the expression. Or we have 5 times a number d. Notice the variable d in the expression. Please take note that expressions do not have equal signs, right? None of these expressions have equal signs. Equations have equal signs. Well, what does it mean to evaluate an expression? That's when you replace a variable with a number and you use the order of operations to simplify the expression. Alright? The standard here today is 6EE2. Read, write, and evaluate expressions in which letters stand for numbers. Some other vocabulary that we're going to need to know. Parts of an algebraic expression are called terms. Terms are separated by addition and subtraction signs in an expression. We have a variable, right? The variable is the letter that represents a number. We have the term coefficient. A coefficient is a number that's multiplying the variable. So if I look at the term 5 times the number p, 5 is the coefficient, p is the variable. Here I have a term without a variable. A term without a variable is called a constant. So in the expression 5 times the number p plus 4, that 4 is a constant in the expression because that 4 does not have a variable. So if we look at some examples here, right, we're asked to identify terms, coefficients, and constants in the expression. Alright, so I like to set up something that looks like this when we identify terms, coefficients, and constants. Alright, so I have terms, coefficients, efficients, constants. Alright, so we just make a little table to kind of organize our information here. And then let's see, the first one's 5x plus 13. That's my first expression. The terms are 5x comma 13. Those are your terms. So it's two terms. Coefficients, the only coefficient is a 5 because the number that multiplies the variable is your coefficient and just the 5 is multiplying the variable. Your constants are any terms without variables. So your 13 would be your constant there because your 13 has no variable in that term. Alright, if I look at my second example, we have 2z squared plus y plus 3. So that expression has 3 terms. All right, has 3 terms in it. Well, my terms are 2z squared, 2z squared is a term, y is a term, and 3 is a term. So there are 3 terms in that expression. My coefficients are 2, because the 2 is multiplying the variable z. Now here's the interesting one. I see a variable, y. Now, even though I don't see a number in front of that variable, it is understood that the coefficient of any variable is 1. Right? So if I have a variable all by itself, I have to recognize that that has a coefficient of 1 because there is one y there. Your constants would be 3 because 3 is not being multiplied by a variable. So we have terms, coefficients, and constants. Terms are separated by addition and subtraction. So 5x is a term, 13 is a term. Notice it's separated by an addition sign. Right here I have 3 terms in this expression. 2z squared is a term, y is a term, 3 is a term. So that's 3 terms in that expression. Terms are separated by addition and subtraction signs. All right, let's look at an example. We have these 3 here. Let me make another table here. So I'm going to have terms. I'm going to have coefficients, and let's see, we're going to have constants. So I make my table, and here we write the expression. So my first expression is 12 plus 10c. Now, first of all, understand that there are 2 terms in that expression, 12 and 10c. So we have 2 terms. Terms are separated by addition and subtraction signs. So I have an addition sign separating the 2 terms. So what are my terms? My terms are 12 and 10c. My coefficients are any numbers that are multiplying variables. Well, the only variable I see in that expression is the c. 10 is multiplying the c. So a coefficient here is just 10. Your constants are any terms without variables. Well, 12 is your only term without a variable. So 12 is your constant. All right, let's look at our next one. We have 15 plus 3w plus 1/2. All right, and let's see. 3 terms. 15 is a term. 3w is a term. 1/2 is a term. Your coefficients are 3, right? And that's it. 15 has no variable. 1/2 has no variable, right? I only see one variable here, and that's the w, and that w is being multiplied by the 3, so 3 is your only coefficient. Your constants are the terms without variables, so your 15 is a constant, and your 1/2 is a constant. All right, let's do the last one. We have z squared plus 9z. Right, so terms are separated by addition and subtraction signs. I see an addition sign here separating these 2 terms in the expression. So my terms would be z squared and 9z. Those are my terms. My coefficients would be what? Well, what's the coefficient of a variable that has no number in front of it that has a coefficient of 1? That is 1z squared. And then my other coefficient is going to be a 9 because 9 is multiplying the variable z. There are no constants in the expression because there are no terms without variables there. Okay, let's write some algebraic expressions using exponents. These are rather simple. Here I have the variable d being used as a factor 4 times. So my base is going to be d, and my exponent is going to be 4, because your base is whatever is being used as a factor. Your exponent is the number of times that base is being used as a factor. All right, so d to the 4th power, would be the expression using exponents for d times d times d times d. If I look here, I have 1.5 times h, but h is being used as a factor 3 times. So if I'm using exponents to write that expression, h is the base, 3 is the exponent. So it'd be 1.5 times h to the third power. If I look at the on your own problems, I have j times j times j times j times j times j. J is going to be your base number, or your base. J is being used as a factor 6 times. So j to the 6th power, or j to the power of 6. In example 5, we have 9 times k times k times k times k times k. 9 is your coefficient. K is your variable. K is being used as a factor 5 times, so you have an exponent of 5. So I would write this expression as 9 times k to the 5th power, because k is being used as a factor 5 times, so that's your exponent. Your base here, the number or whatever is being used as a factor, that's your base, and your base is k. All right. Now we want to evaluate some algebraic expressions. We want to substitute a number for each variable, then use the order of operations to find the value of the numerical expression. That's going to start on this next page here. These are very simple, and we've already done some of these in our warm-ups. So we have the expression a number plus 10. And remember, when we see a variable, I want you to read the variable as a number. So we have a number plus 10 is our expression. I'm going to replace k with 25. When I replace a variable in an expression, I like for my students to use parentheses, right, to show that we're replacing k with 25, and then we're adding 10. So a number plus 10 becomes 25 plus 10, and that's going to be 35 when we evaluate that expression for k is equal to 25. In our next example, the expression reads 4 times the number n. But we want to replace n with 12. So we want to evaluate this expression. 4n is equal to 12. So this becomes 4 times 12. When I replace the variable, I use parentheses. There's multiplication. 4 times 12. That's going to be 48. Let's look at example 6. Right, I'll do it down here. Problem 6. I want to evaluate 24 plus c, or plus a number, when c is equal to 9. So this is going to be 24 plus, instead of writing c, I put parentheses and I put 9 in the parentheses because we're replacing c with 9. 24 plus 9, that's going to be 33 when I evaluate that expression for c is equal to 9. Problem 7. We have the expression a number minus 17. I want to evaluate that expression for d is equal to 30. So in parentheses, I'm going to put the 30 to replace the d, and then we have to take away 17, and 30 take away 17 is going to be 13. So when we evaluate expressions, we simply want to replace the variable with the number, and then we simplify using the order of operations. If I look at our next example, I have the expression a number divided by another number. We're told that the first number is going to be 16 and the second number is going to be 2/3. So this is going to look like this: 16 in parentheses divided by 2/3. And both of these values are in parentheses because they each of these values replace the variable. So then we write this using fractions, so 16 over 1, and we multiply by the reciprocal. It becomes 3/2. Right? When we divide fractions, we multiply by the reciprocal. I divide out 16 and 2. They become 1 and 8. And then I multiply numerator times numerator, denominator times denominator. 8 times 3 is 24. 1 times 1 is 1. 24 over 1 is going to be 24. So we have these 4 examples here. We'll start with problem 8. If you want to try these on your own, you can, right? You'd stop the video, but I'm going to continue. So I want to evaluate the expression of a number p divided by a number q, where p is 24, q is 8. So this is going to be 24 divided by 8, right? And once again, when I replace variables with numbers, I want to use parentheses. It's a good habit to get into. 24 divided by 8 is going to be 3. Well, problem 9. A number q plus a number p when q is 24 and when p is 8. So it's going to be 24 plus 8, and 24 plus 8 is going to be 32. Problem 10. A number p minus a number q when p is 24, when q is 8. So it's going to be 24 minus 8. 24 take away 8 is going to be 16. And then problem 11. A number a number p times a number q when p is 24 and q is 8. So it's going to be 24 times 8. And 24 times 8 is going to be 160 plus 32. That should be 192. Alright, now let's do some more. If we want to evaluate expressions with two operations, let's take a look at this expression here. I would read this expression as 3 times a number minus 14. And we want to replace x with 5. So 3 times a number x becomes 3 times a number, or 3 times 5. So 3 times 5, we put the 5 in parentheses because it's replacing the variable x. We take away 14. This becomes 3 times 5 is 15. Take away the 14, that's going to be 1. If I look at my next example, I want to evaluate the expression a number z squared plus 8.5, and we want to replace z with 2. So this is going to be 2 squared plus 8.5. 2 squared is 4 plus 8.5. It's going to be 12.5 for the value of that expression when z is going to be equal to 2. Okay, let's try 12, 13, 14, and 15. Start with problem 12. The expression reads 5 times a number y plus 1, and we want to evaluate that expression for y is equal to 6. So it's going to be 5 times 6 plus 1. First we replace the variable with the number, then we simplify using our order of operations. 5 times 6 is 30. 30 plus 1 is going to be 31. Number 13, my expression reads 30 minus 24 divided by a number y, and we want y to be 6. So this is going to be 30 minus 24 divided by 6. Order of operations says we have to do that division before we do the subtraction. So this is going to be 30 minus, 24 divided by 6 is going to be 4. 30 minus 4 is going to be 26 for number 13. Problem 14. A number y to the second power, take away 7, when y is going to be 6. So that's being 6 squared minus 7. 6 squared is 36. Take away 7. That's going to be 29 for number 14. And number 15. We have 1.5 plus y squared. I want to replace y with 6. So it's going to be 1.5 plus 6 squared. I have to first replace the variable with the number, and we're going to replace y with 6. I have to do the exponent before I do the addition. So that's 1.5 plus 6 squared is 36. 36 plus 1.5 should be 37.5. Right? Now let's try some harder problems. Right? This is going to be 3 times a number plus 15. That's the expression. I want to evaluate that expression for x is equal to 7. So this becomes 3 times 7 plus 15. 3 times 7 is 21 plus 15. It's going to be 36. Circle or box those answers. Problem 2b. 5 times a number x divided by 7 for x is equal to 7. So that's going to be 5 times 7 divided by 7. 5 times 7 is 35 divided by 7. And 35 divided by 7, that's going to be 5. 2C says to evaluate the expression 56 minus 4 times the number x for x is equal to 7. This is going to be 56 minus 4 times 7. 56 minus 28. And we wind up with 28. And let's try a few more. A little bit more complicated here because we're replacing multiple variables here. And we have x is going to be 5, y is going to be 2. So this is 8 parentheses. That's going to be 5 minus 2. We have to do the parentheses first. 5 minus 2 is 3. So that's 8 times 3. That's going to be 24. All right. Notice that when we simplify expressions, I don't see equal signs. All right. We have the expression a number x take away a number y plus 6 when x is 6 and y is 1. So that's going to be 6 minus 1 plus 6. Addition and subtraction we do from left to right. 6 minus 1 is 5 plus the 6. That should be 11. We have our next expression, which is a number y plus that number y times another number x. Y is going to be 8. X is going to be 15. So that becomes 8 plus 8 times 15. Have to do the multiplication first. So 8 times 15 is going to be 80 plus 40. That's 120. So that's 8 plus 120. That should be 128. Problem 10. We have 15 minus parentheses a number m plus a number p. We want to use m as 3. We want to use p as 10. So it's going to be 15 minus parentheses. That's going to be 3 plus 10. And 3 plus 10, we have to do the parentheses before we do subtraction. So it's 15 minus 13, because 3 plus 10 is 13. 15 minus 13 is going to be 2. And then problem 13, we have a number z times a number y plus 4 times a number y. For y is 5, z is 2. So that's going to be 2 times 5 plus 4 times 5. Multiplication and division we have to do from left to right. So 2 times 5 is 10 plus 4 times 5 is 20. 10 plus 20 should be 30. Well, let's finish up here. Real life application. You're saving money to buy a skateboard. You begin with $45 and you save $3 each week. The expression 45 plus 3 times W gives the amount of money you save after W weeks. For part A, how much will you have after 4 weeks, 10 weeks, and 20 weeks? So you want to set up a little table situation here. So this is going to be, let's see, we have the expression is going to be, let's do part A, do that. Part A is going to be 45 plus 3 times W. And we want to do that for 10 weeks, right? Let's redo that. So part A, that's my expression. So let's do this. We'll set up a little table. So I'm going to have for what? 4, 10, and 20. So we have 4, we have 10, and we have 20. So make a little table look something like this. And then we have the expression, right? And I want to move this expression over here, right? So we're going to move the expression here, and then that's good. So this is going to be 45 plus 3 times 4. This is going to be 45 plus 3 times 10, and this is going to be 45 plus 3 times 20. So we essentially just take our expression and we replace W with our input of 4, replace W with our input of 10, replace W with our input of 20. Then we actually do the math. 3 times 4 is 12. 45 plus 12 is going to be 57, right? And these are dollars, right? That's the cost. or that's how much money we'll save after W weeks. So it's not cost. Oops. That's going to be not cost, but we would call that money saved. That's 57, right? And this is going to be saved. Right? Money saved. And then we have 3 times 10 is 30. 30 plus 45 is 75. So you'd have $75 saved after 10 weeks. After 20 weeks, 3 times 20 is 60. 60 plus 45 is 105. So after 20 weeks, we'd have $105 saved. Part B says, after 20 weeks, can you buy the skateboard and explain? Well, for part B, do that over here. Answer's going to be no, because $105 is less than $125, and the $125 is what we need to buy the skateboard.
Oh my God.
All right, our last problem here, we want to do the same thing, but it says use the expression 45 plus 4W, and we want to, and the question asks, can you buy the skateboard after 20 weeks? So if we have 4 times 20 plus 45, right? 4 times 20 is 80. What's 80 plus 45? That's going to be, right, because that's 80 plus 45, so that's $125. So the answer would be yes, right? Yes, we would have enough money. Right, so that's the end of our lesson. Just remember, when we evaluate expressions, we replace variables with numbers, and then we perform all of our order of operations. All right. Hope that's going to be helpful.